Hello. So we're gonna start chapter 7, vertical separation with Bertrand game. So this chapter is actually a review or numerical example of chapter 6. So just think of it as a review of chapter 6 with new example. Okay, so in this chapter, we try to understand the vertical relationship between manufacturer, retailer, and consumers, especially the strategic interaction and relationship between manufacturer and retailers in the setting of Bertrand game, in one-time game, and infinite horizon game. So let's see, goal of this chapter is to learn how to solve the equilibrium in the separation of time difference to understand the comparison result between these two cases. So we're going to look one time and we're going to look infinite Bertrand competition. Okay, so let's look at it. Part 1, Bertrand vertical separation. Numerical example. Suppose that there are two retailers selling Hyundai automobile. Then they pay the wholesale price W to the Hyundai for each car that it sells and charges each consumer the retail price P. The demand equation for the dealer in the retail market is P equals 50 minus Q, where the price is a unit of thousands of dollars. The marginal cost of Hyundai is $10. So the only difference between chapter 6 example and this is what the company name as changed to Hyundai. So in order to look at different example, we're going to change the demand curve, right? So not P equals to 50 minus Q, but we want to change it into P equals to 120 minus 3Q, okay? 120 minus 3Q will be our new demand curve. And we're going to set the same marginal cost for Hyundai. So let's look at it. So we got the new demand curve, P equals 120 minus 3Q, right? And we have W and marginal cost of manufacture that equals to 10. Do we have any other clues? No. So what it says is there is a two-step, right? We have a manufacturer, we have retailer, and consumer, right? So from here to there, they provide with W, right? And here to there, they provide with P, right? And they purchase the raw material with marginal cost of the manufacturer, right? And we have that as 10, right? So W is what? Marginal cost for retailer, and P is the cost for consumer, right? So since we only have the P demand curve from where? The demand curve from the consumer side, right? The relationship between retailer and consumer, we only have that equation, right? So from here, we'll get the W, right? The demand curve for manufacturer, right? And then we're gonna solve the equilibrium quantity, equilibrium price of price to the retailer and price to the consumer, okay? Okay, so let's erase it and rewrite it. So P equals to 120 minus 3Q, and we have marginal cost for the manufacturer equals to 10. Okay, so in the retailer side, right? Retailer side, let's look from the total revenue. The total revenue for the retailer equals to what? P times Q, right? So the P we have as a demand curve is 120 minus 3Q, right, times Q. And that equals to 120Q negative 3Q squared. So why do we get this? To make the marginal, to get the marginal cost. To solve the monopolies problem, we want to have what? We want to set the marginal revenue equals to marginal cost, right? That is the main concept we're trying to solve with, right? So starting from the total revenue, we get the marginal revenue and set that equals to marginal cost, right? Okay, so we have total revenue like that, and then we get the marginal revenue of the retailer, right? That equals to what? Partial derivative of the total revenue of retailer with respect to quantity, right? So what do we have here? We want to take the derivative of 120Q negative 3Q squared, right, with Q. So we get 120 negative 3 times 2, right, times Q to the power 2 minus 1. So we get 120 negative 6Q. And that's equal to what? That's equal to our marginal revenue of retailer. Now we want to set this marginal revenue of the retailer equal to the marginal cost of the retailer, right? So marginal revenue of the retailer equals to marginal cost of the retailer with the solving monopolies problem, and we get that as 120 minus 6Q, right? And what we want to notice here is what is the marginal cost for retailer. We have marginal cost for the manufacturer as 10. This is not 10, right? So we have marginal cost for the retailer. That is what? Their purchasing price from the manufacturer that we have as W, right? So now we got the W. W equals to 120 minus 6Q. Okay, so moving on, then what do we got? We have W equals to 120 negative 6Q, right? And we already have P equals to 120 minus 3Q, and MC of manufacturer equals to 10, right? And that is what? W equals to MC of retailer. Okay, so we got W, but W is at the same time what? We have manufacturer, we have retailer, their selling prices, W, right? So the demand curve for the manufacturer is not P, but W, right? So W is a demand curve for the manufacturer. So we're going to manufacturer side. Manufacturer's side. So we're gonna look once again the total revenue for manufacturer equals to what? The price time quantity. What is the price for the manufacturer? Our demand curve of W, right? W times the quantity becomes the total revenue for the manufacturer, and here we have 120 minus 6Q times Q. So the total revenue for the manufacturer equals to 120Q negative 6Q squared. Right? So what we want to do, we want to set also the marginal revenue equals to marginal cost, right? So we're doing the same step one more time, right? So now we want to take the partial derivative of the total revenue for the manufacturer with respect to the quantity, right? And that equals to 120Q negative 6Q squared with respect to Q, right? So going there, we have marginal revenue of the manufacturer equals to 120 negative 6 times 2 times Q to the power of 2 minus 1. So we have 12Q, right? And we want to set that equals to what? MR of the manufacturer equals to MC of the manufacturer. And we already have the MC equals to 10, right? So now we have 120 negative 12Q, that MR equals to MC of 10, right? So we have 12Q equals to 110, right? So Q equals to 110 over 12. Okay, so moving on. So now we get what? Now we get P equals to 120 negative 3Q. We got W equals to 120 negative 6Q. And we got Q star, right, equals to 110 over 12, right? So what we can do is, using this equilibrium Q quantity produced, we can get P and W, right? So once we plug the star in, right, we'll get the P star and W star, right? So starting with P star. Sorry again. Okay, P star. P star equals to 120 minus 3 times 110 over 12, right? So we have 120 negative 4, so 110 over 4. And let's get 110 over 4 equals to 27.5. So we get the P star at $92.5. Okay, 5. Yes. And we can get the W star at 120 minus 6 times the Q star of 110 over 12. So once again, we get 120 negative, 110 times 6 over 12, 55. 55. So we get 65 as W star, right? So we can conclude, and let's calculate this also. 110 over 12, 16, repeat it. So we can get the solution as, what is the Nash equilibrium in this game? It's about the price of manufacturer star and price of retailer star, right? So what is the price of the manufacturer? That is W, right? And price of the retailer is P, right? We're writing down W star and P star. So the Nash equilibrium in this case is $65.92.5, right? And the optimal quantity produced is 110 over 12 or 9.16. Okay. So this is when what? When there is one. I'm gonna write down first and then 1 second. So this is when we have one manufacturer, right, and one retailer and consumers, right? So what if we have two? The logic is simple, right? For the W side, it won't change from our model, right? For the price it won't change because we are thinking of, right, what? They are agreed at the monopoly price, right? Monopoly price. And the monopoly price is our P star of 92.5. So now we have to look at if there's a two company making duopoly. What we have to do is to get the total profit and make it half, right? So let's make it half. So if monopoly price is agreed, then the profit for the monopoly will be a price of 92.5 negative the cost of $65, right? P negative W times our quantity of 110 over 12, right? So what we have is 92.5 negative 65 times 110 is 252 and some decimals, right? So let's assume just size of 250, right? So the total profit that the market can get as a monopolist is 250, right? If they agreed at the monopoly price. So what is the profit for each farm? Each farm will get same amount of profit, that is half of the monopoly profit, right? So they will each get 125, right? So and if they don't agree, right? If they don't agree, what happens? The price, right, will equal to the marginal cost of each retailer. That's equal to W. And what happened is the profit equals to a P negative W times quantity. And we have P and W the same amount and get the zero profit. So what happened is if they don't agree, right, if they deviate from the monopoly price, then there will be a what? The punishment triggered and nobody will get the profit ever after. So we're gonna look the consumer surplus of each case. 1, duopoly. 2, Bertrand, one time, right? So starting with 1, duopoly. So what is the price in this case? $92.50, and W star is 65, right? So if we have our graph, right, P and Q, and we have demand curve of what? 120 negative 3Q, starting at 120, and we have our price at 92.5, and our the cost for the retailer or price for the manufacturer at 65. So we can have matching point connected and get Q star at 110 over 12, right? So where is our consumer surplus? Our consumer surplus is right here. So like we did before, we're going to attach the triangle and look at it. 120, 92.5, 110 over 12, and we have 0, right? So as 27.5 times 110 over 12, and we have it half, right? So our consumer surplus will be 7.5, 12, okay. 1, 2, 6, and sum. The consumer surplus at the birth trend one time, right? The second is birth trend one time, right? So what is the P star in this concept? The P star equals to the marginal cost of the retailer, that equals to W star, right? And W star was 65, right? So the retailing price is equal to the manufacturer or wholesale price of $65, right? So if we draw again, right, P and Q, going down with 120 minus 3Q, 120, we have 65 right there, and we have the quantity 110 over 12 right there, and we have consumer surplus of triangle in that area. Okay. So profit for each one will be 0, that is equal to retailer will be 0, that retail profit will be 0, that is P, and at the same time W. And manufacturer has the marginal cost at $10, so the whole square, or I don't know how to call it if it's not square, but rectangular, right? The size is all manufacturer's profit. Okay, so in that case, our consumer surplus has a triangle of 120, 65, 0, and 110 over 12. So consumer surplus is half of 120 minus 65 times 110 over 12. So we have 20, 65, 10, 12, 2, 150, 252. So the part 1 is all about we just talked, and let's move on to infinite horizon vertical separation. Part 2, infinite horizon vertical separation. So we're going to look at one more numerical example with infinite horizon vertical separation. So suppose that there are two retailers selling Hyundai automobile. They pay the wholesale price W to Hyundai for each car that it sells and charges each consumer the retail price P. The demand equation for the dealer in the retail market is P equals to 50 minus Q, where the price is unit of thousands of dollars. The marginal cost of Hyundai is 10, and retailers are competing in a Bertrand game model in infinite time. We assume this is an infinite horizon game with interest rate of 10%. So what is added from chapter 6 is that we have the interest rate to calculate for latter part. So how can we solve this problem? So we're gonna do the same thing, right? We're gonna do backward induction, right? From the back side, from the very ending side, to retailing price, we start and go to W, go to the marginal cost of the manufacturer to get the solutions, right? So we're gonna do the same thing, and after we're gonna look, is 10% enough, or do we have to increase the interest rate to make the agreement goes on? Right. So we see that the profit from one time period vertical separation Bertrand game is 0, right? Since the retailer wants to make positive profit, there comes the incentive of collusion, which two retailers make a deal to sell at the monopolizing price and share the profit by half. The basic setting is same as one-time Bertrand game in part 1. So first we start from the monopolizing price of 40 and quantity of 10. So how do we get it? We're gonna do it, right? And 2, if collusion works, each retailers would take the half of the monopolizing profit. 3, if one of the retailer betrays and charges slightly lower price than the monopolizing price would become equal to the marginal cost of W and both retailers would get zero profit. And 4, to assure the punishment work, we would have a condition that profit from the collusion throughout the time is bigger than profit from betraying. And we are using the present value discount to compute the profit, right? So this is all this explanation how we solve the infinite horizon vertical separation, right? So let's go back to the whiteboard and do step by step. So we have the P equals to 50 minus Q, and MC of the manufacturer equals to 10, and MC of the retailer, which is W, right? And we have price. So starting from the retailer side, the total revenue, right, of the retailer equals to P times Q, right? So P is 50 minus Q, and we got Q, so the total revenue for the retailer equals to 50Q minus Q square, right? And we want to get the marginal revenue of the retailer, that equals to what? The partial derivative of the total revenue of the retailer with respect to quantity, right? So what we have is the derivative of 50Q negative Q square with Q. Right, so we have 50 negative 2Q as the marginal revenue of the retailer, right? To set the monopolizing price, right, we want to have the marginal revenue of the retailer equals to marginal cost of the retailer, that is W, right? So what we got is the demand curve for the manufacturer, W, equals to the marginal revenue of the retailer, which is 50 minus 2Q. Okay, so move on to the manufacturer side. So for the manufacturer side. So what is the demand curve for the manufacturer is the price for the manufacturer, W, right? And that equals to, we just found 50 minus 2Q. Right? So starting here, we're doing the same thing. The total revenue for the manufacturer equals to what? The price times quantity of the manufacturer, right? So we have 50 negative 2Q times Q, right? And equals to 50 negative 2Q square. And if we take the partial derivative of the total revenue of the manufacturer with respect to the quantity, we'll get the Q, right? 50 negative 4Q equals to marginal revenue of the manufacturer, right? As since the manufacturer is a monopolist, right? We have the marginal revenue of the manufacturer equals to marginal cost of the manufacturer, and it is given as $10, right? So what we're doing is 50 negative 4Q, the value of marginal revenue of the manufacturer, matches with 10, right? Then we can get 4Q equals to 40 and Q equals to 10, right? So what we have just found as Q is what? This is the aggregate demand of the market, right? So this is aggregate production size, right? So for each farm, since we're doing what? Duopoly, right? So for each farm, they're going to produce Q1 equals to 5 and Q2 equals to 5, half of the total quantity size, right? So, so Q output of each farm, right? Q1 star and Q2 star equals to 5 and 5, and the total Q, which is Q1 plus Q2, right, is 10. Then what we can do is to find the P and W, right? We know that P was 50 minus Q, and W equals to 50 minus 2Q. So plugging this Q star in, we can get the P star equals to 50 minus 10, 40, and W star equals to 50 minus 20 equals to 30, right? So equilibrium price, the Nash equilibrium for the price of what we looking for. Before, when we have one time, we just look at what? W and P, which is the producing price, not producing, the price for manufacturer, right? And price for retailer. But what we're looking for is now we are thinking about the competition in the retailing price, right? So Nash equilibrium will be not W and P, but P of retailer 1 and P of retailer 2, right? So if they agree, they're gonna charge both $30 and $30, right? And we can say, oh, W star is it's not 30, right? It's 40 and 40. Each charge is 40, and W star equals to $30. Okay, so let's move on to the profit side. So profit of the retailer, the total profit of the retailer equals to what? P negative W times Q. And that's equal to 40 negative 30 times 10, and we get 100 profit in total market. What does that mean is, again, we're taking half of the market, right? Each side takes half of the market. So profit for from 1 equals to profit for from 2 equals to the half of the total retailing profit of $100, and each get $50. 50 units dollars. So what we get it is we want to set what? We want to set a trigger strategy, right? And we want to make the other follow the monopolist price, right? To agree. So let's look at the infinite profit, aggregate profit of infinite time duopoly, and one-time betray of taking whole monopoly profit just for one time, right? So we're gonna look at profit of one-time monopoly, right? Monopoly, and we're gonna look at the aggregate profit for Form 1 and each period summed up, right? For year 1 to infinity. And what we want to do is to set a trigger strategy. So we want to have the value for aggregate, right? Duopoly is bigger, right? We want to set that. And we're using what? Discounting factor of theta equals to 1 over 1 plus r. So let's move on one more time. So we want to set profit of monopoly for retailing, right? So profit for retailing will be better, right? The profit for retailing for one time is smaller than aggregate profit of year 1 to infinity if they agreed on the half of the retailing price at each time, right? Each time, right? So why I have this each time is because we want to use the discounting factor of 1 over 1 plus r, right? So in here, if I say the total revenue of I means total revenue of retailing at ith period, right? So pi r1 means first year's profit of retailing, right? And 2 means second year profit of retailing. But what we want to do is discount it to present value, right? Discount it at present value. So for R1, right, do we discount? No, this is the starting point. So we get just half of the profit, right? Pi R1 equals to half of the retailing profit. What about profit of R2, second year? We get half of the profit of retailing, but we have to discount it to current value, right? So times theta, right? So profit of retailing at times 3, if we discount it to present value, right? They'll get the half of the retailing profit also, but we are having the power, right? The square of theta put in front of this future value, right? And so for Rn, right, if it's nth year, we're gonna have the theta to power of n times the half of the retailing profit. So why do I have the retailing profit as just pi r? Because the market profit size will be same as what? 100, right? The market cap is 100 profit, and each will get half of it, which is 50, right? We'll get 50 each year, and we want to just discount it to current value, right? To get the sum and compare it to one-time profit, right? So one-time profit is 100, and we want to look at if we set theta at which level, right? We can make that all of the summed present value discounted profit is bigger, so we can have the duopoly forever. Okay, so let's look at it. Sum up the profit of retailing for each period from I is 1 to infinity is pi of r, half of it, right? Half of the pi of r plus theta times half of pi of r plus theta power 2 times half of times pi of r plus until n half of pi r, and we're going to make it infinity, right? So there's a simple solution when we have the theta in between 0 and 1, right? So if this is between 0 and 1, we can have the summation for infinitely repeated, right? We can have the initial value of half of the retailing profit there, and we can have power 1 over 1 minus what is powering up, right? Theta. So we can get, this value is the sum of all the future value discounted to present, right? So we have half of the retailing profit 50 over 1 minus theta, right? So what we want to do is to set the sum greater than 100, right? So what kind of theta we can get? So 100 minus 100 theta is smaller than 50, so if we're moving, right, 100 theta is greater than 50 and theta greater than half, right? So if theta is greater than half and smaller than 1, we will have the aggregate profit greater than the deviation of taking monopoly profit for one time. So it will prevent the deviation from agreed price. So we looked at the if theta is greater than half, we'll get what the trigger strategy set, right? So let's come back to the concept of the interest rate. By this interest rate, right? So theta equals to 1 over 1 plus the interest rate, right? So we can get the R, right? 1 plus R times theta equals to 1, and 1 plus R equals to 1 over theta. So we get R equals to 1 over theta negative 1. So when we have the theta is over half, right? So what we get is 1 over slightly bigger than half, right? So slightly bigger than half, so let's say 6. Then what happens? The value of 1 over theta, right, cannot exceed 2, right? So we can see that 1 over theta cannot exceed 2. What does it mean? R cannot be, right, cannot be 1, right? R is strictly smaller than 1, right? So our interest rate cannot be greater than 100%. Okay, and let's look at the real example of the percentage value that we have in the slide. So we have the interest rate at 10%, right? So what we have here is, with our numeric example of R equals to 10%, what we do is, this is a little wrong, right? There's a little typos. I don't know why it happened. Okay. So what do we have is R equals to 10%, and that's equal to 0.1, right? So 1 over 1 plus R, which is theta, right, equals to 1 over 1 plus 0.1, that is 1 over 1.1, right? So if we calculate it, there is a value between 0.90 something, right? So they rounded up to 9.1, and I'll just keep as 0.9 to make it like simpler, right? Then what is the aggregate profit, right? It's half of the retailing revenue, right, times 1 over 1 negative theta, right? So what we get is 50, right, times 1 over 1 minus 0.9. So we get 50 times 1 over 0.1, which is 100. So we can get 500 profit in infinite Bertrand game if they agreed on the monopolist price, right? So what we are comparing this 500 to, we are comparing to 100 of one-time deviation monopolizing profit. So what we see the greater value for the colluding, right? And we can get manufacturer's profit, retailer's profit, and the consumer surplus.